Physics is the art of solving mysteries and understanding why things work the way they do. The question becomes, why does physics use so much maths, and why do we find maths everywhere? To answer this question, I've come up with my own insights in this idea. So, first question is, we know what multiplication, addition, and subtraction is, but what does it actually really mean? If I add two quantities together, I get 5. So if I add 3 quantities here and add 2 quantities there, you end up with 5 quantities. What does the addition have to do with any of that? What addition basically means is count. And another way of saying count is it quantifies something. So it quantifies 3 and 2 to make 5. One of the properties of addition is that you can only add things of the same property. Example, if you had 3 of the same cups and you added them together, you can get 3 cups. However, if you had a cup and a mug and you add it together, you can't get an answer. But like I said, you can define its properties. If there's a liquid in the glass, in the cup, which is 1 unit, and there's half a unit in the mug, we can say they both have a property of having a liquid. So that will become 1 unit of liquid plus a half unit of liquid, and that quantifies into 1.5 units of liquid. Where does that come in use? Well, the internal energy. We define this as the total energy subject to a system. So something we have an interest in, it could be a room, it could be a chemical reaction, it could be the entire universe, which is an isolated system, is defined as the internal energy, the total energy to that system. So what is it? It is the quantification or quantifying all of the possible energies you can have. And the truth is, we might have sound energy, heat energy, electrical, light, potential, etc., but it all comes down into 2 types of energy. One being kinetic energy, that would be your sound. It's the oscillations of those air molecules. Heat will be the jiggling and jittering about of those molecules when you're heating them up. And it will be potential. So the potential energy is the energy associated with an object due to its position. So yeah, the energy associated with an object due to its position. Those are the only 2 types of energy we currently know of, and that is what we define as the internal energy. Next question becomes, what is subtraction? Subtraction is used, again, you can only use it with when you're talking about same properties of an entity, so 5 balls and 2 balls, while it will not work with a glass and a cup. So if I remove 5 balls from 2 balls, I get 3 balls. So what's actually happened? I've removed them, but there's another way of looking at this. It's also asking the question, what's between 5 entities and 2 entities, which would be 3. Between 5 and 2 are 3 things. Use your fingers, you'll have 5 fingers. So if I want to know what's between these 2 fingers and these 5 fingers, there is 3 left. Where does that come into use? Well, in acceleration, which simplified means the capacity to gain or lose speed, we have the final velocity minus the initial velocity. Those are all the variables. What does it mean? It means what is between the final and initial velocity is what v minus u is. And we will come back to what division means later. Multiplication. If I multiply 2 entities together, 2 and 3, I get 6 altogether. That will be the same as 3 times 2. All it means is to repeat one entity that number of times. So I'll repeat 3 2 times and I get 6. That will be the same as 3 plus 3. But what does it mean when I multiply 2 variables together, such as Newton's second law, where force is equal to mass times acceleration? Well, to understand this, we'll bisect it. So imagine this square grid is 4 kilograms. So each of these little small squares is 1 kilogram. So that's a kg, this is a kg, that's a kg, that's a kg. So now we have 4 kilograms. And now let's say I have an acceleration of 2 meters per second. And I break it down into 2 1 meter per second units because we've come up with units. So that's 1 meter per second. So that's 2 meters per second. What multiplication basically does, it basically combines these two quantities together. In what way? Well, because scientists have to agree on units, such as the kilogram. Why is that? Because life would be very difficult if everyone had a different definition of a kilogram. I could define a kilogram by the weight of a 15-pound dumbbell, or I could define a kilogram by the weight of a 3-pound dumbbell. So we have to come up with a way where everyone can agree on the kilogram. And because we did that, whenever we have an object, we can basically break it down into that kilogram. So maybe if I had a chair, it could be made out of 4 units of kilogram. And maybe if I have an acceleration, which applies here too, I come up with a meter per second, but I might have 2 meters per second. And what this multiplication does is basically rebuilds that system. So basically, this isn't an object that's divided into smaller units, it's still that same object. So what it does, it gives each single one of its elements. So this kilogram, 2 meters per second, this kilogram, 2 meters per second, this kilogram, 2 meters per second, this kilogram, 2 meters per second. To all together, so all of the object, so this entire mass is moving at 2 meters per second. Simplified, what multiplication means is has a when it comes to variables. Example, the force that we measure is basically the mass that has an acceleration. Acceleration being the gain or lose of speed.